So a very good morning to everyone. My name is Mahathir, or Matt for short. I'm the sales manager for Majulah Controls based here in Singapore. We are the authorized representative for Nova Smar for some countries in Southeast Asia. And also good evening to our team from Brazil, Mr. Libanio, Mr. Ricardo, and Mr. Chang for making time for us in their evening to share a webinar today. The title is Automation Technology and Trends that are Empowering Digital Transformation. I think most of you already know Smar. Nowadays, we call it, the company is called Nova Smar. We've been around for 46 of 2021, so 47 years. So we are really, I would say, a veteran in the industrial automation world. And most of us know Smar for being the leaders or being the pioneers for a protocol called Foundation Field Bus back in the early 90s. So the idea for Foundation Field Bus, we still see it reflected today in being Smart's push for an open, non-proprietary control system that is used by all end users, that which does not tie all end users or lock all end users into any single protocol. So the 3 points, the learning points that we will learn, Smart will share today, is about having an open control systems. Number one, how the foundations of the industrial process automation are currently being improved. So there are a few standards nowadays to improve standardization and open technologies. They will also share the convergence of the usage of IT technology into the OT environment, as well as there's an initiative started by some major end users, which is called OPAS, an open process automation system. And we hope this will drive the real power and productivity benefits for the drive for digital transformation. So digital transformation is a term widely used not only in our process industries, also in consumers. So it's something which is like how the internet has revolutionized the world. I think in the future, digital transformation, AI, and these technologies will transform the world again. So without further ado, let me hand the presentation over to Mr. Ricardo Turazzi. Ricardo.
Thank you, Matt. Let me see here how I can share the display. Well,
Matt needs to stop sharing.
Oh, yes, now I can. Yeah. Thank you, Matt.
Okay, sorry about that.
Oh, Matt, I think you need to give me permission to share. I'm getting a message here.
Sorry, 1 minute, yeah.
That is deactivated. Well, while Matt enables me as a presenter, I would like to say good morning to everybody there in Singapore and in other parts of Asia. It's a real pleasure to be here with you. My name is, I will just give you a quick introduction about myself. I'm an electronic engineer and I'm working in the process automation industry for nearly 25 years, always in suppliers of automation systems and instrumentations. And currently I'm working with Nova Smar in the software area. So it's a really exciting job. We are always involved in new technologies and the real cutting edge technology of process automation. So it's a very, very exciting environment for ourselves. And we have here with us also Mr. Libanio de Souza is our president. Libanio would like to say a few words before we start.
Yes, just say that it's a pleasure to have this opportunity to talk to you. And SMAR has been following all these developments in the world. And we are glad to bring you this news and all that you'll be incorporating our solutions, and it will be a pleasure to help you to use this new technology.
Thank you, Libanio. Matt, are you seeing my blue display right now? Yes?
Yes.
Great.
Yeah, we can see it.
Great. So we can start now.
All right. Thank
so
you.
Today the webinar is about how the automation technology is empowering the digital transformation. So starting here, this is our agenda for today. We're going to talk a little bit about the key global technology trends in the industry. And then we're going to talk about how the foundations of process automation are being improved through standardization to support these technology trends. Then we're going to talk about two major initiatives for open automation. And then we're going to talk about some key technologies that are, as we can say, the backbone of this open automation. So it's going to be a lot of knowledge here. So for those of you who are already familiar with some of these technologies, I think it's going to be easier. Maybe you will know most of what we are going to talk. And for some of you that is hearing this for the first time, it's normal that you don't get everything at once, but it's a good starting point to study more and try to figure more how this technology evolution is going on. So that's a great content here. And this is really the cutting edge technology trends in process automation. So going through the key technology trends, we had a couple of weeks ago, the annual ARC event. They have an industrial summit every year. And during the January of each year, they release the key technology trends. They have a publication they call the ARC Insights, key technology trends for 2019 that we have here, 2020 here, and 2021 here. So what I was trying to show to you in this slide is that we've been talking about digital transformation for many years now. And we can see that if we analyze here how it's changing from 2 years ago up to now, we can see that the concepts of digital transformation are really evolving. I think the market is assimilating more these contents. So you can see here in, excuse me, in 2019, some technology trends were merely single technologies, and now we are talking more about more open and broad concepts. Sorry, like for instance, the technology convergence morphing into technology fusion, the operational resilience becoming a key objective, remote operations, automated operations becoming autonomous operations. This is what we are seeing in many other fields other than the industry. The cars are going through the same direction. So all these are related to digital transformation, and also clouds and edge computing becoming a really important part of these architectures in the industry. So if you analyze these technology trends, we can see that many of them are related to many attributes that a process automation system must have in order to address these requirements. We can see, for example, if you're talking about technology convergence between IT and OT, we can see that cybersecurity, for example, is a big issue, is a big attribute that the control system must have in order to support this. We can see in all these fields here that digital transformation is all about data, right? So the data plus, if you put this data in some context, you get some information. And from that information is where you get the benefit, the real benefits of the digital transformation. And you can use all these technologies, asset management that we have for many years already, and some new technologies like digital twin, artificial intelligence, machine learning, analytics, digitalization. And these things go on and on. For example, if you're talking about technology convergence, edge computing, we go through orchestration, which is a big thing in the IT area, which is moving. We're going to see that it's moving to our process automation sector as well. We have many other things like connected workforce, collaboration. We are seeing more and more, especially now with the COVID. Before, some industries already had that. For example, in oil and gas platforms, they invested a lot of this. But now with the COVID, we are seeing that all the companies are invested in remote work, collaboration between offices apart geographically. So this is something that we are going to see in every industry. Some other attributes like interoperability, portability, configurability are attributes that are going to support some of the technology trends. Tighter integration, more connectivity to support the data and digitalization. And we can see that there are a lot of things that we need to think about to support these key technology trends that the market and the industries and the users are demanding. And in order to better support all these trends, we really need better standards and more open technologies to make all these attributes of automation for a process control system easier to handle all these requirements. So we're going to talk a little bit about how the process automation standards are being improved and some key technologies related to it. If we talk about the emergency process automation standards, we can probably the two most important ones are the OPAS, the Open Process Automation, and the NOAA, the Namur Open Architecture. And we're going to detail a little bit, give you an overview about both of them. Starting with OPAS, the Open Process Automation. First of all, it's important to mention that the OPAS is the standard, right? It's the Open Process Automation standard. And this standard is created by a forum, which is called OPAF, Open Process Automation Forum, which is one of the forums of the Open Group. The Open Group is actually a global consortium that enables the achievement of business objectives through technology standards. So they basically leverage the technology standards that already exist and try to apply them and make a better solution for many things. And the process automation is just one of the forum, and they have many others. So it's a really big group, this thing. And if we look about the OPAF, the Forum for Open Process Automation, it has many very important companies working there. We can see here end users, we can see here process automation system suppliers, we can see here IT companies. So it's already a picture of this IT-OT convergence and the necessity of digital transformation. A simple slide like this already can tell us many things about what's going on. In SMAR, of course, we are participating very strongly. SMAR actually has a tradition of investing a lot of, as Matt introduced in his presentation, SMAR, since the beginning of, for example, the HEART Foundation Field Bus, the OPC, the FDT, EDDL initiatives, SMAR has always been involved. And I have Libanio here in my, besides me. Libanio, it's very important that he is here today because he participated personally in all of these technology developments. So he has a lot of baggage and he can contribute a lot for us SMAR. And as we are open and collaborative company, we can collaborate to other companies like yourselves and do that, everything. This next slide is a overall picture of how would be the OPAS, the Open Process System architecture. I'm not going to go through all the details over here, but I just want to point out that everything that's in yellow is related to the OPAS components. So we have some important components here, like the OPAS connectivity framework, which is the network that connects everything together. And the DCN is the distributed control nodes. We have a distributed control and very important concepts as well. And everything that is in blue, it's the what we can say the legacy systems, the PLCs and the DCSs and many others, which can be integrated in the OPAS architecture. And one important point that it's important to mention here is that an open architecture like this can bring to the users many benefits. And if you think about the financial benefits, this slide here compares what would be a typical CapEx model using the today typical systems that are marketed for the industry compared to what will be the OPAF CapEx model. So starting here in the typical CapEx model, we can see here this blue curve. It represents the capital expenditure. So the initial capital expenditure is very high to make the initial investment to have the system up and running. And then the spendings get reduced just to maintain the system up to the point when you need to do an upgrade. So you have another investment here and then just maintain the system again. And your efficiency here is this dotted curve. When we start up the system for the first time, we reach an efficiency level. It goes flat here. And then some time in the future, when we need to do an upgrade, we're going to have to do some time of plant shutdown where you have no efficiency. And then when you have a new version, you get a little bit more efficiency. And if you compare here with the OPAF model, the initial investment, you can see here is going to be a little lower than the traditional one that we have today, because it uses open technology. So you're going to have more competition among the manufacturers, and the end users can select the best breed of every piece of equipment that they need and software. And as the system is going to be much more flexible, as we're going to see today, the companies will be able to use this flexibility to handle the data with context, digital transformation, and improve their efficiency to higher levels. So this is a summary of what the companies are searching for with all this digital transformation and the open technologies. This next slide is one example of a current solution that we have today and how it can incorporate the OPAS. Here we can see This is the system that Smar have. And one very particular thing that we have, which we consider an advantage in comparison with the other suppliers, is that our architecture is very similar to the OPA's architecture. We have distributed controllers. We have this for 20 years, and we can handle many different technologies. And our architecture already uses a backbone of communications with the foundation field bus high-speed Ethernet. So Smar has maybe one advantage that it's going to be much easier to migrate our current architecture to an OPA's architecture. So if you play a little bit with the colors, our users that already have our systems will just need to replace a few controllers and the software here to have an OPA's compliant system, and they can also keep their current installations functioning. And then we're going to have, for example, in the same backbone, we can have different protocols, high-speed Ethernet, and all the communications from the OPA's communication framework, and all the distributed applications, which Smar has been doing for 20 years. And now we're going to be able to do this as well, but using the OPA's standard. So for us in Smar, it's going to be not very complicated to change our current system to the OPA system. Talking about the standard releases, this table here shows that the OPA's standard is divided in 7 parts from the technical architecture that we showed previously, talking about security, profiles, connectivity framework, system management, information models, OPC-UA, alarms, and all the control languages here. And we have already released one version in 2019 for this part. In 2021, we have already released the version 2. It's called here a preliminary because it's open to the market it's open to the public for comments and everything. This is actually 2020. It's wrong here. This is slide, I'm sorry. And for 2021, we have for Q1 updated. All these parts are being updated. Some of them are going to be released for the first time. And for the second and third quarter, these other parts are going to be upgraded. So it's still a work in progress. We already have a version, but it's being under progress in most of the parts yet. So it's very new technology and definitions. And if you're talking about comparing all these parts in the standards that are involved, this is very important because the OPAS is called the standard of standards. So it's not a standard that creates new things from scratch. It basically selects the best standards available and put them together to make a process automation system. So for the technical architecture, it uses the ISA 95, security, these other standards, which is ISA 99, it's IC 62443, and goes on. We have, for example, the OPC-UA, which is a very important, it's in all the architecture, we have OPC communications. You're gonna see more details about it. We have another standard, which is gonna be very important, and it is this thing, the system management or orchestration. It's becoming a key part of open systems because it's going to make it much more easier to manage everything. We're going to see in the slides in the next slides. We have automation markup language, which is going to be allow many configurators, many software configurators from different suppliers to exchange configurations and having things like portability interoperability. We're going to see more details about it. We have many standards for alarm management and automation programming languages, function blocks, and IEC 61131, which has 5 languages, the ladder logic, function blocks, structured text, SFC. We're going to see more details about it as well. Another standard that the OPAS has already embraced is the process automation device information model. We're going to see more details about this technology, which is being organized by the FieldCon group. And finally, the Ethernet APL. And the OPAP is watching very closely the development of this. And this, for sure, is going to be part of the OPAP architecture. It's related also to the field level communications initiative, which is also part of the OPC technology. So it's a lot of standards and a lot of technologies, but what I wanted to tell you is that everything is connected. It's like a bunch of pieces of a puzzle that they're being put together to make a very good and open process automation system. We're going to see more details about the most important technologies here. So just making a summary of the OPAS central concepts, it was really being created, this standard, to address the digital transformation requirements. And a very central concept is that an open architecture, flexible, and everything that is going through with OPAS, it's going to be made possible to do low-cost implementations, change implementations. So it will drive the real power and productivity of the digital transformations related to the ability to make rapid changes, interactive and data-driven innovations. And here, at the end of this slide, we can see the 4, like we can say, the pillars that were like the principles that drove the development of this standard. It had to be a distributed, modular, extensible, and scalable platform. Had to be standard-based, open, interoperable architecture. It had to have security in the design of the architecture and the components, and had to be less complex and more productive user environment, because if it's too hard to use, nobody's going to use it. So these 4 pillars were used as principles to drive all the developments of the technology. So that was a quick overview of the OPAS. Now we're going to talk about another initiative, which is the Namur Open Architecture. And the Namur Open Architecture it's really about 2 data paths. One data path of communication is what they call the core process control. This is the legacy control systems, the DCS, the PLC, which we already have today. And in parallel with that, what this architecture is bringing is a different communication path around, not through the control system, but around the control systems, to enable the digital transformation, to enable, for example, the data from here to be extracted and send it to the cloud and to other applications, to be monitored and optimized. So it's really like keeping the current status of the control systems and integrating it using a parallel infrastructure, as we can say. Looking at this other slide here, we can see here that there are some communications between the core process control and all the structure for monitoring and optimization. This standard is not released yet, so they're still developing many things, but we can say that they have some building blocks here, which are very important. For example, they have here what they call the diodes, which allow communication from the core process control, and it's going to have security in this. So in order to not bother the control system, and some other concepts for the integration. And they, of course, they're going to have the proprietary interfaces as well. And many people see advantages and disadvantages of this architecture, but one thing that we can foresee is that, for example, this architecture is thinking about additional sensors. And if you think about new measurements and everything here, it's hard to think. Our experience in the history tells us that every time you have a new information here, you're gonna want to use this information in your process control. So we're not sure exactly if this is gonna be like this in the future. It may be as we can see, this NOAA initiative and also the OPAS standard, they use very similar technologies. Both of them uses OPC UA. We're going to see that both of them are going to use the Ethernet APL. So what we believe is that these two initiatives they're going to merge some point in the future. I don't know if it's going to be sooner or later, but it's very clear to us that they're going to merge in some point in the future. So those building blocks that I mentioned before, there are these 5 blocks here. They have a standardized information model. They call the NOAA information model based on OPC UA. So the same way that for the OPAS, they are using OPC UA as a backbone of communications. They have the NOAA diode to enable security. So they are worried about security as well. They have a NOAA verification of request component is also related to security. They have the concept of the NOAA aggregating server, which is going to be a server that's going to aggregate many informations and handle big data communication, as you can see. And they are going to have additional sensors for monitoring and optimization. And for all this, they're using OPC UA, they're using process automation, a device information model. They're going to use Ethernet APL. So we can see that the technologies being employed here are also being employed in the OPAS, in the open process automation. That's why we believe it's everything converging to the same thing at some point in the future. If we talk about those technologies that we already mentioned briefly in the OPAS and the NOAA architecture, let's talk a little bit about OPC UA. The OPC UA, we are seeing that it's growing and growing very much in the market. We can see here in this slide that it's very much used in the process automation. It's a key technology for the OPAS, for the NOAA, and it's being used also in many other sectors for many other associations and companies. So OPC UA, we can see that it's becoming the real industrial interoperability standard. So they have a communications to everything, which we can see in this slide here. For example, they have communication between the IT and OT world. They have communication to the cloud. They have security for remote access. We have local communication between controllers. We have local communication, controller to controller, controller to field devices. It's going to be possible now with Ethernet APL and everything. It's going to have wireless integration with the 5G technology. And it has an extensibility framework which will allow the implementation of new communications that are not even foreseen today. So it's prepared for today and it's being prepared for the future. So they're getting, as you can see, communication from sensor to cloud. And talking about this field level communications initiative here, we can see that it's changing the automation pyramid that we have in the Purdue module, where the field devices only communicate with the control systems, PLCs, and the PLCs communicating with the SCADA systems, then to the business systems and the corporate systems. And now with these new technologies, the sensors are going to be able to communicate directly to many things, including to the cloud. So it's a really big change. So this field level communications initiative of this part of the OPC Foundation, the OPC UA, it covers many requirements of industrial automation. It includes, including the Ethernet APL, it's going to see somehow, the Ethernet time sensitivity network, and in the future coming technologies, 5G, Wi-Fi 6, and etc. So it's going to cover all this. And making a summary of the OPC UA technology, we can see here 4 very important points. So the technology previews a very complete information model framework. So it's object-oriented, very flexible and extendable. They have models for data access. Everything that we already have with the classic OPC, data access, alarms and condition, historical data and events, and many others. And they have also the OPC access types or communication types, for example, client-server communication for supervision, pub-sub communication for control communication. And they have several different protocol bindings. The familiar one that we are already familiar with, the TCP, UDP, but they are incorporating also the new cloud technologies, MQTT, JSON, cloud, brokers, so very broad range of protocols. And they also have the OPC UA discovery with the local discovery server, global discovery server. So they have a lot of security related technologies using certificates and access protection, authentication, authorization, auditing. It's a very complete technology. It's really becoming the backbone of the open systems. Going now to the process automation device information model. It's about making a standard for the messages of all these different technologies. If we think about the foundation field bus, the heart, the Profibus, wireless heart, each technology, they have their existing protocols with different structures, different information models, but basically they represent the same information. And the goal of the process automation device information model is to make every different technologies, the intention is to make this communication, the messages, how this information are communicated in a standard way. So it's what they call the unified information model, which is going to be protocol agnostic, which means doesn't matter which protocol are being used, the information is gonna arrive to the control systems, to the asset management systems in the same way. And this technology is being controlled by the FieldCom group. The OPC Foundation is also part of it. Profibus, Profinet International Organization is also part of it. And it's really about standardizing the message. So the message, it doesn't matter which protocol is being used, the message will arrive in the same way. And this is very important for digital transformation, because when you handle a large amount of data, it makes it a lot easier for the software and the advanced tools to analyze everything if they arrive in a standard way. So it's a way to empower digital transformation as well. So the implementation of this process automation is going to use OPC UA and OPC UA for devices as well. There's going to be the field device integration server, which takes account of several tasks over the entire life cycle, including communication for configuration, commissioning, diagnosis, and calibration. These are typical asset management types of communications. And going through how it works, we can see here that we can have devices from different technologies, in this example, HART and Profibus. And one way to do this is through an FTI server. And the FTI server, they enable access of different technologies in the message, you can see here that the message is the same despite the different technologies. And it can be done also directly through OPC UA. So there's two ways to bring the information from the devices. For the legacy devices, which don't have OPC UA capabilities, we use the FDI server to bring the information. But if we are using a new device which already handles OPC UA directly, we can use the native OPC UA to bring the information. And the information will arrive in the same way, doesn't matter the technology, the protocol. Another technology very important, used especially now in the OPAs, is the orchestration technology. And the name of the technology being adopted is the Redfish. One thing which is not common knowledge in the automation, in the OT market, is what is orchestration. In the IT, it's more common knowledge, but for the OT people, it's not very known. So orchestration is about automating work process. For example, if you need to install a new hardware, what we do today is everything is manual. You install the hardware, you power up the hardware, you configure the hardware, you load the software, you configure the apps, connect to the networks, and do a lot of process manually. But with orchestration, these tasks can be changed to be handled automatically. For example, in order to install a new hardware, there is going to be a manual step where you need to physically install it. But after it's installed, all the other steps can be done by a software, an orchestration-based software. And this technology is maybe one of the technologies being used in the OPAS standard, which is probably, we can say, that is causing the better impressions. The people that are already testing this technology are getting very, very impressed positively by this technology. So orchestration is about making the management of the system easier. It enables, is a form by which you can have assemblies of systems and components, which is going to be the OPAS architecture, for example, and manage it in a much easier way. The goals of the orchestration is to have more security, more reliability, easier management, and at the same time have more flexibility, more openness, and more interoperability. And without industrial orchestration, these attributes here are mutually exclusive. For example, if you want more security, you cannot have openness, because the more open you have, the less security you have. If you want a more reliability, you're gonna have less flexibility. But what's magic about everything here, that it makes possible to have both, the best of the both worlds. So it's a really important thing in open process automation. And summarizing here the orchestration, what they can do, it coordinates and manages multi-layers of digital infrastructure, including the applications, virtualization, which is another technology with the Dockers, and which is being used. It's going to be used more and more in process automation systems, networking, security devices. So it automates, for example, software deployments for new devices or entire systems. It automates maintenances and upgrades of applications and software infrastructure. It self-heals the digital infrastructure to maintain continuous operations. For example, should a device or a piece of software fails. It can handle redundancy in this open architecture, open process system architecture, where the hardware and the software are detached. You can have the application softwares moving from one distributed control node to another, and everything is managed automatically by the orchestration. For example, if a field device fails and you need to replace by a new one, the orchestration can configure automatically the new one, saving a lot of work from the instrumentation people. So it's about really automating what is being done manually today. The standard being used in the OPAS is called the Redfish. It's organized by the DMTF, which was formerly known as Distributed Management Task Force, which is also a non-profit organization that creates several technologies always related to the system management and interoperability. And what I wanted to bring to you also is some quotes from test labs. Because, for example, for the open process automation, we have several test labs already testing and making trials. And the goal of this trial is to contribute to create the standards and make it better. So, for example, there is a lab in Houston. It's coordinated by the company ExxonMobil, and these codes are from this test lab. This first code is going to be from David DeBerry, which is a very experienced process control engineer from ExxonMobil, and he coordinates all the tests that are being done in this lab in Houston. And he was really impressed with the orchestration. We can see here some quotes that he said. He said, "It's funny, we talk about new technologies and our IT friends tell us they've been doing some of these things for 15 years. So it's not new technology. I mean, it's new technology for the OT, but it's not new technology for the IT. And this conversion is contributing a lot with the open process automation." And he said more. He said, we have never seen anything like this before. He was really impressed. And these things keeps going. He said, you feel like you found a treasure, or you discovered something that hadn't been seen or understood before. The ability to turn what used to be a very manual process and that take days and weeks to accomplish as a human being doing certain tasks, and to see the same tasks done, in order of minutes or hours using technology that is available. That's a real step change to our world. So the tests are going very well with the orchestration. The people involved are getting really good impressions, as we can see here in this David DeBerry. And there's actually a video on YouTube where you can see they speaking more details about this. If you go on the YouTube in this link or looking for next generation IT/OT convergence, a pilot with ExxonMobil, you're gonna find this. Okay. Oh, Libanio just told me we have only 10 minutes, so I'm gonna have to speed up a little bit here. We have other quotes also from ExxonMobil. The other quotes we have from Steve Bitter, who is the Research and Development Manager. He also mentioned here some very, very impressive things about the technology, how it's remarkable simple to do the setup. The demonstration gave them the confidence that the technology can really be used and adapted to accomplish all the things that the open system requires and also the requirements for the open technology. And he strongly believes now that orchestration has got to play a very significant role in open process system designs. We have another quote from Harry Forbes from ARC as well. He's also very impressed with the technology. He says that this technology is going to make the open process automation systems much more flexible than what they are today. Not 5%, but 500 times more flexible. So all those changes that we mentioned before, we have strong indications that they are really going to be possible. So moving to security, as we can see with the open process systems and all the connectivity to cloud and everything, of course, we're going to have to need more security. And the standard that the OPAS selected, which is the part 2 of the OPAS standard, is the IEC 62443, which is the same as ISA 99. And this standard was selected because it covers most of the requirements of the process industry. If we compare here with other security standards, this orange square here, which represents the IEC 62443, it covers most of them. So this is why this was the selected standard for the open process automation standard. And another important thing about this standard is that cybersecurity is not something you simply buy, install, and you have cybersecurity. It's much more than that. That's why this standard is divided in 4 parts. One part for the components, another part for the system itself, and another very important parts are for the policies and procedures and general things, which means it's not enough to have a system which is compliant to the standard. The end user procedures and how they handle and maintain the systems is very important as well. So we have seen these parts here in order to complete an industrial automation system. The standard covers everything. And this is one example of how the life cycle of the security can be handled. So the product supplier, the companies like Smar and many others, have to develop the systems and components according to the standard. The system integrator has to make the systems with components from several manufacturers, and they have to be configured for the intended environment of that particular end user. And the end user also has to operate and maintain the systems according to their requirements. So it's a complete life cycle of security. It's something that everybody is responsible. Moving now to our automation markup language. The automation markup language is the standard that was selected by OPAS to make this thing possible. It make possible having, for example, the engineering tool from one supplier and the engineering tool of other supplier, and they will be able to export and exchange AML files. So the configurations and setups of the system can be done using one software from one supplier, and the software from another supplier can make modifications, imports, export, and everything. So it's about portability of configuration. So we can see here that the control system configuration can move from different suppliers. The standard used is the AML, Automation Markup Language, IEC 62714. So it basically allows end users to move their process control applications between different supplier tools. It's a very much related to the openness. So the end users are not going to be tied to one single supplier for configuration engineering tools. This is a summary of the automation MEL organization. It's been there for many years already. It has developed and maintains the standards. Talking about the part 6 of the OPAS standard, we have the automation MEL information model. There is it's incorporated the alarm management standards, ISA 18.2, IIC 62682. There are a standard for function blocks, OPAS function block. This is actually a contribution of SMART because the OPAS standard will give reference functionality of control blocks with sample code based on ISC 1131. And this was actually a donation. SMART donated the source code for the standard, and it's going to be available for everybody. And the standard also uses another standard for function blocks, which can be used in the OPAS systems. And another standard that can be used is the IEC 61131, which handles the most typical control languages, ladder, function blocks, structured text, instruction list, and sequential flow chart. It's important to mention that the suppliers don't have to have everything. They just have to implement whatever makes sense for their offering. This is how it looks like, the automation markup language. So it's a way to standardize all the contents of the automation configuration. And finally, to close our presentation, I'm going to talk about the Ethernet Advanced Physical Layer, which is actually an evolution for the instrumentation. I think most of you have seen this slide many times. It basically talks about the technology evolution for instrumentation through time. So we had first the pneumatic sensors communicating through pneumatic signals. Then we had analog sensors with analog signals. Then we had the first digital instruments with the heart communication. It's already a digital communication, processors in the instruments. And then we have all the field bus, foundation, Profibus, device net, wireless heart, and everything. And now the next big technology evolution for a field device is going to be the Ethernet Advanced Physical Layer, which is a physical layer that can handle multiple protocols. The physical layer is going to be based on Ethernet, so it's very known, very powerful. A smart instrument, it can handle many things. For example, in a smart solution, we do control in the field. One smart instrument can handle nearly 20 different function blocks, PIDs, signal selectors, calculation blocks, and so on. And we have several clients that they do the control completely in the field instruments. They don't need controllers for the control. And this is a technology that we do with Foundation Field Bus for 20 years. And now with Ethernet APL, which is going to be much more, it's going to have much more resources in terms of communication bandwidth, processors, and everything. So we can only imagine what we're going to be able to do with this new technology. And everything is driven by the demands of the end users of higher efficiency and lower costs. So it's about data. The end users are already talking that the advanced physical layer is the missing link between to enable the full digitalization in the field. For example, with technologies like HART and Foundation Field Bus, because their communication speed is much slower than the Ethernet, it's much more difficult to bring data from thousands of sensors to, for example, an asset management software. But now with the APL, it's going to be much more faster, much more capable of handling really large amounts of data. And data plus context is information, which is the basis for the digital transformation. And then we can think, why Ethernet was not used before, and it's being used now for field sensors. It was not used before because it didn't have a solution for some of these requirements, which were the industry is used to use twisted pair cabling for field instruments. The devices are powered by the same pair of cables, loop powered devices. It's necessary to have long distances, 1,000 meters, for example. It has to be deployable in explosion hazardous area. It has to be easy to handle. And Ethernet APL, it handles all these, it has a solution for all these requirements of the process industry. It can use the twisted pair of cable running up to 1,000 meters. It can be used in hazardous area. It's easy to handle. It has connectors for harsh environments. It has up to 60 watts of power in the trunk for the Ethernet. So it's the standard is handling all the requirements of the process industry. We can see here in this table, for example, the summary of the technical attributes applicable to it. So we have the standards. It's based in both IEEE and IEC standards. We already mentioned the 6 watts of power. These are the standard organizations involved in these initiatives. So it goes 1,000 meters. It can use the same Type A cable that is used for field bus foundation. So it has everything, and it has a huge amount of communication power. This is another slide showing here that using shielded single pair of cables, using this 10 base T1L, which is going to be the physical layer for the IC, you can run 1,000 meters for the trunk and 200 meters for each spur. This is another comparison between the Ethernet APL to the other communication. So we can see, for example, field bus that used to be the most powerful, the higher speed communication is practically nothing compared with the Ethernet APL. So it's gonna enable a lot more, to do a lot more things in the field. And as this standard is this. I'm gonna go quickly here. I just wanna mention that the standard is gonna be released this year. It has already many things done, and some things are being concluded, and it's gonna be released this year. And just to close up everything, with the Ethernet APL, with the very capable field instruments, we're gonna be able to have many control capabilities in the field instruments. So each field instrument will be like a distributed control node as well. We will be able to do many things in the field. There are gonna be several systems that don't even need dedicated controllers because the field instruments will be able to handle everything. High communication, a lot of processor capability and everything. So this is what we see in our future architecture with the OPAS, OPC, PubSub, and taking the power also of the Ethernet APL.
So very reliable, because it's the control, you be in the act, and that closer to the field device, to the acquisition and the actuators. And with the orchestration, that will be very easy to maintain and improve the system.
Great. So, Matt, that's it for now. I'm sorry, I think I extrapolated a little bit the time. And if you wanna go for questions now, we are open.
Yeah, thank you very much, Ricardo, for a very clear, comprehensive presentation. I think there's a lot, as we can see from the presentation, there's a lot of technologies, there's a lot of standards that goes into having an open system that can do a digital transformation. I think if you really want to go in depth, this presentation has to be maybe like a 1 or 2 day event.
Yeah, maybe 1 week.
Yeah, maybe 1 week. So Ricardo being able to cover whatever he covered, you know, Ethernet APL, OPAS, automation, ML, orchestration within an hour is really fantastic. So thank you very much, Ricardo.
I appreciate it.
I open the questions to the floor. If there's any questions, you can type it in the chat, or if you prefer in the Q&A. And Libanio, if you want to add anything before we close, please.
Yeah, just say that all this new technology, you be transparent for the user. So we are able with this orchestration to put all this together and make it very easy to operate an open system. So what the user needs to do is to look for open solutions, because that's what will enable the real implementation of the digital transformation. If you have open, then you can integrate. And the integration is the main advantage of the digital transformation. That's it.
Okay. Thank you very much, Mr. Libanio, for the comments. So far, okay, there's a question coming from Mr. Daniel Tsai. Can you provide some list of already deployed Ethernet APL? Ricardo, do we already know of any sites or installations already for Ethernet APL?
I think there are some trials, but not real actual production installations, because even the standard, the final standard has not been released yet. By their schedule, the standard is planned to be released this year, and then the manufacturers will be able to develop their products based on this, and then start marketing and selling. But one important thing is about APL is that it's a physical layer. I mean, for example, in Smart, we already have all the technology for the foundation field bus. So we will only need to have a different physical layer, different electronics, but the software is going to be very easier to implement. So we believe that it's not going to take long for the solutions to be available to the market.
And Smart participates in a demonstration with other suppliers of APL technology. So by the second semester of 2021, we'll be integrating and demonstrating this technology.
Okay. Thank you, Ricardo and Libanio. We have another question from Mr. Kaushal. Redundancy in Ethernet APL. Do we have redundancy for that?
Yes, it's going to be optional. The users are going to be able to do simplex topologies and also redundancy. This is a good thing about using a known technology like Ethernet. Ethernet, there are already a lot of solutions in the market for redundant switches and everything, and all those will be able also to be used in the Ethernet APL.
Okay, so I hope that answers your question, Mr. Kaushal. Is that okay? Yeah. Okay. So, any other questions from the floor? Also, we will make the recording of this presentation available to anybody who is interested. So the contact details are up on the screen now. My email address, my contact, and also the Smart personnel. So feel free. If there's a lot of information to process and many little bytes and pieces of different technologies. So in case anyone of the participants has any questions after the presentation, please feel free to contact us. Sure, we will send the recorded copy of this presentation, no worries. And please, end users, system integrators, please feel free to share with your instrument team, your colleagues in the department who might not be able to join today's meeting. I know it's in the morning in the plant, there's a lot of meetings going on, so it's a bit difficult to attend a webinar. So once again, I thank you, Mr. Ricardo and Mr. Libanio, Mr. Shang, for spending time with us today, this morning, and giving us a very nice presentation. And I also thank all of the participants who took 1 hour, more than an hour of your day to join this presentation. So so that's it. We'll be organizing more events, hopefully in the future, webinars. So yeah, we'll be in touch. Thank you, everyone.
Thank you very much.
Bye-bye.
Thank you.
Bye-bye. Thank you. Cheers.